So hi everybody and welcome back to this C++ tutorial series for absolute beginners. This is video 227, and in this video we talk about states, and actually there are different kind of state diagrams, so we have to be careful. For example, here I opened up in Wikipedia site this finite state machine, and actually, like I said, there are still many other diagrams which also are state diagrams, and important is that we understand which diagram to use. And on this side, for example, on this finite state machine side, you can see we have here on top a diagram with an example, with a real world example, because this picture here below is actually this state diagram here is a representation of this turnstile picture here. And we will talk about this in a moment more, but before that, don't get irritated with other style of diagrams. You can see representations of different state diagrams. You can see we have here this representation is also, they have other entries, descriptions, and so on. And careful about this representation, because this one looks already like a flow chart diagram, but this is not a flowchart diagram. That's very important, because flowchart diagram and state diagram are different, and I will show you this in this tutorial and in the next one, because that's very important that you understand the difference about a flowchart diagram and a state diagram. Very important for programmers. And yeah, you can see here some more other representations. Important is we take the most easy representation as possible, and the reason for that is because diagrams should help you as a programmer to understand the program, right? That's the reason why we use all these diagrams. They should help you, they should not confuse you, and that's why we will try to use the easiest diagram as possible. Easy means not that you understand it easy. Easy means just it represents it's easy, so that you understand it later easy after you know what a state diagram is. And when I scroll here a little bit more down, you can see a little bit more complicated things. Not this one is nice, but this one here, this one is also nice, but this one we will skip, because states are represented in the theory from you can see from mathematical models, and they are describing this in theory like this and this. Like I said, if you want to go at once in future, learn a little bit more math, then you can learn this in depth. But as a programmer, we don't need math, and we are anyway not interested in practical programming about the mathematical representation, because this one is more a theoretical approach, and we as a programmer are interested in practical programming. And practical programming, when I scroll up, it's more like this one here. The first example is very nice. And why is this first example so nice? I show you that. First of all, we have here a real world object, and I hope you realize what this is. I don't know the English name. I could call it now a turnstile, like this they described it here. So this one is nice, because this one you can find, I don't know where you find this, anywhere where it should be blocked, in train stations, or I don't know. I found not many of them, but there are places where you can find something like this. This here is rotation metals, you can see this, and they are blocking you, so you can't walk through. And you can work through when you throw in a coin. So if you throw in a coin, this machine gets unlocked, and then you can push this metal here and can walk through, right? That's a real world object, and we as a programmer, we can simulate real world objects, because that's our goal. We can, doesn't matter what out of the world is, we can simulate it, we can write a program for it. And the nice thing about this one is they already give us the state diagram, which means this representation on top, it's the state diagram. And as an additional exercise, you can try to write here a program for this one. So a little program, it's not too difficult. You don't need to make it, but if you will try it, it's nice, because then you will understand this state diagram, which I'm going to explain more in detail, probably in the next video with this diagram, because I will show you the code and then also in detail how this states work. But I think I will talk about the states right now here a little bit more. First of all, I talk so much about states. What is a state actually? I have never told you what a state is. A state is, I want not make this example. Like I said, I want to show you this probably in the next code with the code example, and you should try it on your own. I want to show you the states first in our code, which we created. Like we created this sort function here, right? And when I created this sort function, you probably remember this diagram, this layout here, where I started, okay, this one here I put from Wikipedia. That was this bubble sort little picture, and they had their 4 nodes, and they had some numbers, and then there was animation, how the numbers went from this part to this part. And I said, yes, that is what I want code in my sort. So the problem here is, this here is one representation. This is one possible input, right? We know this is a list input here. So with other words, when I started my programming, I programmed all my code so that this input will work. What I mean with that, this input will work. Input will work. I said, okay, I have 4 nodes. Then I said, okay, I need to sort this 4 nodes, a pointer here, an end pointer there. And then the pointers have to swap this 2 here. And then the pointers must go to the next line and then swap here, go here, and then start over again. So I worked only with this start condition. Yeah, so I have here the 4 nodes, and my whole program, what I wrote at start, was at this point, right? So my whole program, I expected I get here 4 nodes, and then I wrote my code and it will work. That was how I started. And let's call this here state 1, and S stands for state, and 1 state just this is the first position. In my case, we can make also the start. You saw already the start is indicated with this arrow here, but actually in my case it's not the real start. That was just how I started to develop my code. Because that was the thing what I found in Wikipedia. Here's my start point, but that means not this is the real start of later of the call. So, all right, let's say I'm finished with that. I have coded this, right? I showed you all the things what I made here. I made here my swap. That was anywhere the swap function here. Here was the swap, so I can swap them, and then I have set my pointers to the next position here. After they swap them, they should go, and then my while loop, that was the whole big loop here. This while loop will then loop here through till my while loop will find an endpoint position. That was all the nice things, but this S1 was, like I said, made for this 4 node input. Input means when I start, let's go here in main. Here is my main, and where is it? Here is my main function, right? And my main is saying, okay, I give you here is the sort. Here's the sort call. I call you the sort with the score list head 2, which is my head here, actually this one head, and I use that what was here before, and that was 4 entries. That was this 4 entries. That's why I have here 4 entries, right? This 1, 2, 3, 4. The point is now here, okay, what happens if your sort algorithm has not 4 entries? So let's say I give you a list, because this input can change, right? Here because normally you make a sort algorithm, so you can sort any list, not only this one specific list with 4 nodes. You want to probably sort any length of the list. Let's say a list with 1,000 entries, or a list just with 2 entries, and so, right? So with other words, I have to consider what happens when the list have different length, and different length means here a different input, right? The input means here this call here, this list here has a different length. It's not 4, let's say, and you can see, let's say it has no, let's say just for this case here, I call it without a list at all, because I have, let's say I have no list. That can happen too in the real world, right? In our world, I have no list because it's not there. It's not loaded. It's not created. And at this point, I have no list. And this is another input, for example. Here, let's call this as 2 because state 2 means this one and this one is not the same. And why is this not the same? Because my algorithm here, which I coded really at start, very nice, all the things here, what I showed you here on top. You can see that this one will not work with this state here. And why it will not work? Because you can see here I assign my pointers, and here I try to compare. But if I have no node, how I can assign pointers here? I can't assign pointers, I can't compare, and I can't even loop here because I have not this options, right? And that's why we have to say, okay, wait a minute. Here, when I have nodes, I have to use the code in a different way when I have no nodes, right? And that's we indicate with states the situation which we have, the input. And very important is we differentiate this with input. Input is how much we get. If we have an input of 4 nodes, we can say, okay, here we have 4 nodes, then you can go here. This is my input here. Then you can do this one, because S1 means my code will work, which I started. But when my input here, this one has no nodes, I can't go with this input. Let's write this S1 perhaps a little bit more down so I can show you this a little bit better. Or let's scroll this down. Yes, let's scroll this down. So let's say I have no nodes, which means here I should not go here, because this indicates this is the input, and the input can't go here. Why it can't go here? Like I showed you, there is no node. Node means I can't assign here pointers, I can't compare. So this is not possible. And then we ask in programming, okay, that means the whole code what I made here for this one will not work at this point. So what I have to do then? Yes, then you have made a special condition for this one, and this one must go here, and that means let's erase this one here, because that's not possible. That would cause an error. All this kind of stuff here. Now this is faster. And then we have defining just and then we have this other state, and which means now I have to think about code how I can handle this one. But the question is, wait a minute, I need now this code, but I need also a code for this position when I have nothing. And you can see what I did here. I just included this this position here because this one is easy to handle. If I have no nodes, I can't use this whole sort algorithm. This one is a very big part. Let me show you this big part here again. Here's my function. Here it starts. And then here's this while loop. This while loop means I can loop most times, and that's why I have here the condition. This is this big code here, which will work with this one here. But this while loop will not work with this one here. So in this case, I could say, okay, if I have no for example, I could say now, if I have no input here, let's say no nodes, then you can't go into this while loop at all. So with other words, I will not let it here in. But you can see what I made here. Let's see what the while loop is checking. The while loop is checking loop end position pointer. This while loop is not checking this one. This is the problem. This while loop is just checking an end position pointer, which means I can enter this one here in my case. And let's see if I catched it before. Oh, I have already checked it because I thought I still can enter the while loop, but I catched it beforehand as well, because here on top, before the while loop starts, I made here a special condition, also a special check for this situation. So when my input is no node here, that was this one here, I check here head of linked list param, that is this one here. And if there is no, if this one is not equal null ptr, then there is a list. But if this one here is null ptr, so the head here, this head here, if this one is null ptr, that was set at start, which means it has not created a list. And here I said, okay, that was not a good solution. I wrote here this comment. Normally I made here a throw that was exercise purposes, but normally here you would say, for example, to the user interface, you go to the option menu back and say, there is no list. You can give options to load list or create list and something like this. You would not throw here. Throw means all time stopping the code. That was, like I said, I put here just a throw for, because I wanted to repeat the try catch block. All right, but I hope you understand it. But the important part is here I catch the state. So this entry input, no node, you go to the state two. S2 means this part here. In my case, throw, but in real, let's write here. In real, you go back to option menu to load or create a list, something like that. This is not the real thing what you do here, but this one is that what you would do here at this point. All right, so I hope you see what I'm after. I want to show you that you as a programmer has now to find all possible inputs which can lead to a problem. What I mean with that is, again, let's start here again. I started here developing my code with this one. But here I only considered that I have an input of 4 nodes. And then I developed my whole program towards this 4 nodes. And this towards this 4 nodes will work because let's say I made all right. But this one is just S1 as state when I have 4 nodes. Then comes the input just let's say with 1 node, and we can see now 1 node will not work here because here I use pointers and comparison. If I have no node here, I can't use pointers here for first node and second node because I have no node at all. And I can't use comparison. So the whole code what I made here is almost not usable for this input here. And that's why I need here a special coding section. And that's we say state2. S2 is no input, you go here. And this S2 here will be more descriptive where you say instead of S2 you can write, this S2 is again a placeholder. In real you write here no nodes. For example, to more descriptive, no node state. This is the real state, no node state. Here you can say, here, interesting is here you write not 4 node states. Interesting is here, you can see I found the no node state. Then I have here 2 node state. This is also a special state. Let's say here 2 node state. Again, this one you can shorten this one. This S2 would be a placeholder. Again, this is a special case. Why is this a special case? Which we have to cover in code as well. The point is in a choose node is here I can set the first. Oh, sorry, I missed one. I missed one case. That was the 1 node state. Sorry, here is the 1 node state. Let's write here 1 node. The 1 node, S2 is the one node state here, this one here. And you can see we have here an entry, and here I can't use the code which I made at start at 2, because I can set the first pointer from the first code, but again, there is no second node here. So which means I can't use the second pointer, which means I need a special code section for this one too. And this one needs to go to the state 2. And let's see, when I have here one node, I have to catch this case too. So anyhow, I have to find in my code where I catch this. Normally, the best way is not to mix them up. The easiest way is for every state that you make them a separate code section. That can cause a little bit more code, because sometimes you can try to try to combine. For example, if I have here already a part, you can try to combine this here, this one, but this combination leads most time to problems. Normally, I would rather prefer to make for every state a separate code section. What I mean with separate code section is like that, what I showed you here. No node, right? Don't mix this no node state. This no node state was here. I checked this separately, and this while node here, this one here would be the S1 here. S1 is this one, has its own section. The node here has its own section. That would be here, this else part here. And then for this one node, the best way would be that you have a separate section for this too. But I think I made here the bad solution, which is with one node. I checked it here in this while loop. And that's not good, actually, because this is, yes, it makes a little bit less code, because if you make for every state a separate code section, that will blow up your code, but it is more clear. So it's normally better. And I made here, I put it here in the while loop, which indicates that you are entering, for example, this state. So I would say this is not good style of mine, because can it irritate, but of course it's less code, because I have then here this check anywhere. For example, I think that is this state here. Here I make this check. First I have to check that there is something, and then here I check if one of them is set. You can see if one of them is set, and then I check the state here where it's only one node. So this solution is not good. This one here, I would rather put this one here out of this while loop. Okay, it will cause me to, like I said, the code will become bigger and bigger, because now you make for every state a special case, but it is more clear for the programmer, and it is more sorted, right? Every state is clear, every position can be fast found. More code is sometimes better than less code, I would say. In most cases, the complexity goes down when you make more code, because you make every part for its own. And if you try to make less code, the complexity goes most time up. What I mean with complexity, you can see now here, you have to think two things. Is this while loop for this one, or is this now for this one? You can see I already think one more than normal. If, for example, if this state would be outside, then I know, yes, there, I think not 2 times, I think 1 time. Yes, it's one node, it goes that, and that's it. And because I put it now here in this while loop, which is more my code where I go to state 1, I have to think, oh, wait a minute, this is not the S1 state with my while loop. This here is a separate state, which is in my while loop included, which is S2. Anyway, I think you get the idea. And the last thing what I want to show you here before I stop here, and is let's make this one fast finish. So you can see in my code there was again a problem. This 2 node state, it's again not the 3 node states, because this one is again a special case. I can't use this code here. So then I wrote here 2 node, for example, state. Again, instead writing 2 node, you can write here as 3. And this is again placeholder. And this input there. And then we have to go to the what I want to show you fast is, wait a minute, this one can go on and on, right? Normally what happens if here we have 3 nodes and then 4 nodes and then 5 nodes, that would cause all states, right? And that's not true. And interesting is why it's not true. Because after 3 nodes, you will realize the 3 node here, let's say I have 3 node, this 3 node setup, right? If I have 3 node setup, it's the same like a 4 node setup. They are the same. Behavior, it's same. Because here I programmed it with 4 nodes, but behavior of a 3 node and 4 node is same, because here I used here 2 pointers, I make a swap and I set a end pointer and null pointer. And if I add here 1 more, it's exactly the same like this 3. Because I adding here no more code in it. All the code description is enough with 3. So if I add here 4 nodes, 5 nodes, it's still going to this S1. And that's what we have to talk also. So after 3 nodes, also the other nodes here are not the same, right? You can see here, no node, it goes not S1. 1 node, I can't use the second pointer, so I can't use this code here. It goes not to S1. Second node, I can use the first pointer and the second pointer. You can see, oh, I can use them. I can use here a swap. Whoa, I can use a swap. Why I can't go in S1 then? Normally you would say, hey, you can go here in S1. No, because here in this code, I use a while loop. In my case, this one has no while loop. You are just pointing, swapping, and then you are finished. You can't loop because here is nothing more to loop. Here's no more end. So this one goes also not to S1. That's why I have here this S3 pointer. So this one goes here to our S3 point. Oops. Let's make this so. That one must go here to my S3 state. But after 3, I can. After 3, so if I have now 3 nodes, for example, 2 node, let's say I have here 3 node. 3 node can go back to S1. Here I can go here. The reason for that is I can set here the first pointer, I can set here the second pointer. I can make like here swap, but I can use the while loop, which was here implemented in my S1. So I can go to the next position and then it will find anyway interrupt. That's it, what I programmed here. That means 3 node can go to S1. If I have 4 node, which is this one here, by the way. This is my 4 node. This is anyway S1. And my 5 node, so let's say if I have 5 nodes as well, which means, let's say I have another input with even more, and it doesn't matter, it will stay here all time in S1. So all other states will go, all other inputs will go to S1, because I can, which you can see this input means, can I use this code here? Yes, you can. Can I use it with 5 nodes? Yes, I can use S1. Can I use it with 4 nodes? Yes. Can I use it with 1000 nodes? Yes, you can use S1 with 1000 nodes because it's defined. But you can't use it with 2 nodes S1, because then the code which is trying to solve this code is not running. Can you use it with 0 codes? No, I can't, because I use in S1 in my code here these pointers, and if I have no nodes, I can't point to anything. You can't use this here. That's why you need here your own special code. Here in S1 with 1 node, you need your own special code. S2, you need again your own special node, and for all other inputs, what comes after that, you don't need your own special input, because this S1 here, which is my while loop, will cover this up. All right, that was here this one for my code a little bit. I hope you understand this a little bit, but don't worry. That was just an introduction, and in the next video I will explain you this example here, and I will show you also this here, this real world example. I write for it a code. You can try it too, please, if you want. It's very simple. and don't to make it too complicated. I watched it already a little bit. There are 2 functions which you really need, but of course you can make more, depends what you like. But in my case, I will make only 2 functions and then 2 settings, and then I can model this one, and then I explain you here the state. And this one here, I will then show you also a little bit more in states. By the way, I can, after we talked about states a little bit more in detail, how this input here is shown, because here I showed you only, with this one, I showed you only what states are. States are a code which you can use with, and which are the input. So it depends on the input. You can use a special code. In my case, if I have here 4 node inputs, I can use this S1 code. That would be my while loop. Here, that would be, I can use this while loop. You know where it is. Anywhere here, this code here, you can enter this while loop. But if you have an input of no nodes, you can't use this while loop, because the while loop says, hey, I want set the first node, the second node, I want compare, but how I should do this? So instead, you go here to another state which handles this input on its own, because we need to handle this situation, right? That was that. And in the next video, like I said, I want to show you this connections between states here. Right now you see how we can go perhaps from this state and what it means going from this state to this state or backwards and all this kind of stuff a little bit more. And again, very important, don't worry about the mathematical part, because that is not so easy. This is just anyway a mathematical model. So if you are interested in math, of course you can go here a little bit more in depth. But then you should learn math. This is for a programmer absolutely not important. And here the last sentence is, why is this important for us to know the states here? Actually, for us as a programmer, it's important to know the states, because these are all the possible inputs. And your program, which I wrote, for example, like I said, I wrote here, I started with this one. And if I would not react to the other possibilities here, then this program, what I wrote, would just use this 4 inputs or 5 inputs, because I showed you that this 4 inputs is so configured that I can have even more inputs, and it will work with 4 inputs, with 3 inputs. Even after 3 inputs, 5 inputs, 1000 inputs will work, but it will not work with 2 inputs. It will not work with 1 input and will not work with non-input. And the problem is, in programming, if this happens, let's say anyhow the user give you a list like 2 inputs, then this will be not sorted. So your program is not sorting a list. For example, let's say he gives this 2 nodes. The first was 63 and the second was 50, and your program will say, I do nothing, right? I do literally nothing, even there are nodes. So the point is, as a programmer, we have to find all possible inputs and all possible states, and the states are the code reaction to these inputs. You can think about this. All time the state is representing a reaction to our input, because later you will see also in this diagram here, which we will talk in the next video more in detail. Oops, not this one. This is the diagram, this one here, this is this one here, that here the input can change the state, but it must be not the change. And then in the next video, I will also show that you should not confuse state diagrams with flow diagrams, because this one, careful, I don't know if this is good, because this looks more like a flow chart. In this case, it is defined as a state diagram with other meanings, but flowchart and state diagrams are absolutely different. In the next video, I want to show you this in this little example, and also in my code perhaps again. But important is, you can try to write here a little exercise again. Try to convert this little picture here to a code. Write a little C++ code. It's very nice. And then when I talk about this state diagram, you will understand this even more. And then perhaps we make also here a flowchart about this picture, because it's so small. This is really a small function program here, and it explains a lot. And the best part is that's all what we need to know as a programmer, that when you understand that we have to cover all states, that's it. And then we can go on with our exercise, which I will. So if you have any questions or any suggestions like all time, write it in the comment section. See you in the next video, and I hope you try this little exercise too, because you train again these classes. You can train the class as well. And yeah, with that said, have fun, never give up. And if you make errors, no worry, that makes only you better if you try to solve them. And as a programmer, bye, good luck, and see you next.